Turn it off.
Take out your scientific notebooks. I need your homework out in depth as well as the sheet we went over yesterday for you to review it. Before you talk about what we're doing today. All right. Give me a thumbs up when you have your notebook in front of you. And your sheet. Thumbs up, thumbs up. Alright, so what I'm going to do, I'm going to pull the name from here. You're actually going to tell me a physical or chemical change you witnessed for your homework. You're not going to say whether it's physical or chemical because we're going to learn as a class whether it's physical or chemical. So when I call your name, just tell me a change that you saw, physical or chemical. But you got to let us, that's the only piece of information I know when I call your name, okay? Miss Amber.
Lit birthday candles.
Lighting birthday candles. Raise your hand if you think that's a physical change. Raise your hand if you think that's a chemical change. That is a chemical change. Alright. Mr. Ben.
Eating dinner.
Eating dinner. Raise your hand if you think that's a physical change. Raise your hand if you think that's a chemical change. Alright, hands down. And we're going to hit on this as we go over our sheet that we did in class yesterday. Depending on what you view, it could be both. Now, if you eat dinner and you eat a ham sandwich, someone said who said they ate a ham sandwich? A ham sandwich? You had a ham sandwich last time, I guess. So if you eat a ham sandwich and you eat it and you put it in your body and you start digesting it, that's a chemical process. You don't get that sandwich back, it's going to come out very different. If you look at it from the point of view of what the food you ate, you just took a part of it away, it hasn't changed form, it's still just sitting on your plate. So depending on what you view, it could be considered a physical or chemical change, because when you tear something away with your teeth, that's cutting, or it's tearing, is something we talked about with our paper. So that could be depending on, but that's why when we give examples and when you look at your life, you really have to think about each change. Madison K. Crumpled paper. Raise your hand if you think it's a physical change. Raise your hand if you think crumpled paper is a chemical change. It is a physical change. Remember to raise your hands sometimes. All right, and one more before we go to the home assessment we did in class. Lauren. Ms. Lauren.
The plate broke.
The plate broke. You broke the plate last night?
No, it's not dishwasher.
Oh, it fell at dishwasher. That's unfortunate. So raise your hand if you think that's a physical change. Breaking your plate. Raise your hand if you think that's a chemical change. That is a physical change. I'm using Ms. Madison's picture. Okay, everyone have a look at your assessment. The physical or chemical change worksheet we did yesterday. When I pull your name, you're going to read out what it says in the box. You're going to start top left, and you're going to tell me if it's a physical change or chemical change. You're going to tell me why. Mr. Jake.
Light a match. It's chemical because it puts off heat, light, and cold.
Okay. Mr. Raoul, cutting a cake.
Physical change because
Someone
someone has to cut it.
has to cut it. Okay, so you're cutting the cake, you're taking it apart, it's a physical change. It's a tricky one because we watched a video about baking a cake. Baking a cake is a what kind of change?
Chemical.
Chemical change. Or if you lit the candle on top of the cake, what kind of change would that be?
Chemical.
It'd be a chemical. All right, Mr. Evans, the next one.
The fireworks is chemical. It makes sound light.
Makes light, makes sound. Once a firework explodes, can you put it back together?
No.
No, it's exploded. And that's the big thing with physical change. The first question you need to ask yourself is, can I reverse the process? Can I put it back together? Can I change it back easily without having chemistry? Miss Sarah.
The physical change did not change color. The shape is different.
Okay, bending the copper pipe is a physical change. If I bent this folder, bend your folder. But it is a physical change, bending, cutting, tearing, something that you could probably, if you bend it, you could probably bend it back pretty easily. Alright? Miss Elena. It's a physical change, we use that example a lot. Madison W.
It's me.
Oh, yeah, there it is. Okay.
Leaves changing colors in the fall is a chemical change because leaves changing colors are chemical because color changes can't do it.
Okay, this was probably the most commonly misinterpreted one. This is the one that most of you got incorrect. You guys did really good on this, but this one was a tricky one. This is actually a chemical change. When a leaf changes color, what happens next to that leaf? It dies, it falls off, it disintegrates. It's not something you change back. The big thing you see is the color changing. And when you look at your handout, color change can be a physical or chemical. But the question you have to ask yourself is, can you undo it? And you can't undo that because it's dying as a chemical change. Okay, next one. Mr. Caden.
Chopping wood, physical change because the tree, you are just hitting it with an axe, basically.
Yeah, you're just hitting it with an axe. So that's pretty much cutting. You're cutting a tree, yeah. So if I had a piece of wood and I split it in half,
It's still wood.
It's still wood. It's not a new substance. It's nothing about it is really become a new substance. Okay? We chose to talk about this one because someone used it for an example for homework. Ms. Tiffany.
Physical change because
Okay, so if you look at it like I'm breaking off crackers or tearing a ham sandwich in half or those kind of things, that's a physical change. You haven't produced any substance. But you're talking about eating food, like actually putting it in your mouth and it goes through your stomach and you have all of these chemical reactions happening. We used that number yesterday, how many chemical reactions are happening in your body in a second. It's a big number.
37 times 10 to the 21st power.
That's it. That's per second. So whenever we talk about the human body, its internal processes, there's a lot of chemical changes going on. Okay, and the last one, Mr. Jamal.
It is a chemical change.
Because why? All those things happen. It's producing a gas. Whenever we did the vinegar and the baking soda yesterday, whenever we, yes sir?
I know the gas,
Yeah, the gas, what gas is it?
carbon dioxide.
It's carbon dioxide. That is written CO2. Okay, so let's just do that, because you brought it up real quick. Alright, so this is carbon dioxide. How many atoms of carbon's in here?
One.
So that's one carbon atom. How many oxygen atoms?
Two.
That's two oxygen atoms. Okay. That's very basic chemistry. Cool. All right. I need you to turn to the next page in your science composition notebooks. I need you to write, this is also going to be chemical concepts, is mixtures and compounds. Alright, so write that in your notebook and then label it in your table of contents for me, please. Give me a thumbs up when your group has got. Alright, so these are actually glasses I brought from my house, and so I need everyone to pay attention. I need you guys to talk, we have for 30 seconds about what you know about these words. I'll have to set up.
Mixtures are compounds are
Alright, 3, 2, 1, voices off. So what I'm going to do is, I'm going to show you mixture, but we're gonna talk about what happens when you get a mixture in a compound, just two substances that come together. Okay, so I have 3 glasses. 1, 2, 3 glasses, okay? If you need to pop a knee or position yourself where you can see a little bit better, that's fine. It shouldn't take any noise, you guys should not be talking. All right, so what I'm going to do is first I have water, and I got some sugar, and we're going to combine these things. So we're going to figure out where the sugar and the water goes. All right, this will even come here for a second. You're going to make sure I don't cheat. So what I'm going to do is I'm going to weigh my water out. Okay. And everything we weigh is going to be in grams, okay? So you clear that out. What's that say? That's 0, okay? So we're going to pour some water in. Okay. I want you to take a marker and write that number on the board behind me. Okay. All right. I need you to put grams in here. Always remember to put your label in here. A lot of times in science, you're gonna have to take measurements, and you just say, I have 148, that doesn't mean anything. Because if you have a number, it's cool. That's not very helpful. So this is just sugar. If you eat too much of it, you'll be unhealthy.
But it'll taste good.
Say really good. Don't touch the scale. If you touch the scale, I'm gonna mess it up. All right, write that number. All right, so we have 148 grams of what in this cup? Water. Okay. And we have 54 grams of what? Okay. So, it's actually the scale using the kitchen all the time. Whisper to your neighbor how much you think it's going to weigh when I add these two things together. All right, voice off, 3, 2, 1. Voice off. Okay, write that number on the board. Okay. All right, now, everyone see this? You see the water? Where's sugar at? On the bottom. Yeah, I'm not gonna drink that.
I'll drink it.
All right, talk with your table group. How much you think it's gonna weigh now? All right, 3, 2, 1. Voice off. You gotta do this real quick. Because whenever we clear it off, we have to take account of the weight of the jar. So as we switch back to the glass. All right, write that number on the board. Everyone have to go back and have a seat after you write that number. All right, have a seat. We're gonna talk about this. All right, voice off, 3, 2, 1. So, raise your hand if you thought the water with salt with salt. With the water with the sugar would weigh less when it was mixed together. Okay. Put your hands down. The thing about matter is we have a rule, we have a scientific law called, and this is something you're